Today, we discuss further wireless LAN's media access control. The media access control sublayer is responsible for the channel access procedure, protocol data units addressing, frame formatting, error control, and the fragmentation and reassembly of the service data units. The sublayer also provides options to support a security service through authentication and privacy mechanisms. The media access control management services are also defined to support roaming within an extended service set and to assist stations in power management. The IEEE 802.11 Media Access Control Protocol is specified in terms of coordination functions that determine when a station in a basic service set is allowed to transmit and when it may be able to receive protocol data units over the wireless medium. It defines two coordination functions, the distributed coordination function and the point coordination function. The distributed coordination function is required for all stations, which provides support for asynchronous data transfer on a best effort basis. Under this function, the transmission medium operates in the contention mode exclusively, requiring all stations to contend for the channel for each packet transmitted. The point coordination function is optional, which may be implemented by the access point to support a connection-oriented, time-bounded transfer of service data units. Under this function, the medium can alternate between the contention period and contention-free period. During contention-free periods, the medium usage is controlled by the access point. No need for stations to contend for channel access. The distributed coordination function is based on carrier sensing multiple access with collision avoidance CSMA-CA protocol, which we learned in the last lesson. The figure shows the basic CSMA-CA operations. All stations are obligated to remain quiet for a certain minimum period after a transmission has been completed toward interframe space IFS. The length of the interframe space depends on the type of frame that the station is about to transmit. High-priority frames must only wait the short IFS period before they contend for the channel. Frame types that use short IFS include acknowledgements, clear to send, data frames of segmented service data units, and a few more. The point coordination function in the frame space PIFS is intermediate in duration and used by the point coordination function to gain priority access to the medium at the start of a contention-free period. The DCF interframe space DIFS is used by the distributed coordination function to transmit data. If channel is still idle after DIFS period, ready station can transmit an initial protocol data unit. If channel becomes busy before DIFS, then station must schedule back-off time for reattempt. A station that completes a frame transmission is not allowed to transmit immediately. In IEEE 802.11, carrier sensing is performed at both the air interface, referred to the physical carrier sensing, and at the MAC sublayer, referred as virtual carrier sensing. The channel is busy if either sensing is busy. Virtual carrier sensing is used by a source station to inform all other stations in the basic service set how long the channel will be utilized for the successful transmission of a protocol data unit. The source station also sets the duration field in the MAC header of the data frames or in the request to send and clear to send control frames. All stations adjust network allocation vector to indicate when the channel will become idle. In practice, stations can choose to never use RTS and CTS, particularly if the data frame size is small and the communication medium is lightly loaded. The figure shows a timing diagram that illustrates the successful transmission of a datagram. When the data frame is transmitted, The duration field of the frame lets all stations in the basic service set know how long the median will be busy. All stations here in the data frame adjust their network allocation vector based on the duration field value, which includes the short IFS and the acknowledgements followed in the data frame. Stations can choose to use RTS and CTS whenever the service data unit exceeds the value of RTS threshold, or to always use RTS and CTS. The figure shows a timing diagram that illustrates the transmission sequence of the frames. We can see the overhead of RTS and CTS frame transmissions impose additional delay. Wireless channels cannot handle very long transmissions due to their relatively large error rates. Large service data units may require fragmentation to increase transmission reliability. The collision avoidance portion of CSMA-CA is performed through a random back-off procedure. The point coordination function is an optional capability that can be used to provide connection-oriented, contention-free services by enabling polling stations to transmit without a contention for the channel. The PCF function is performed by the point coordinator in the access point. We omit the details here for the point coordination access.